Hello everyone, a very warm welcome to this video. In this video we are going to talk about cluster setup. We've seen so far what we are going to cover in this course in the previous video. The agenda of this video is setting up cluster and how the whole cluster thing works. So let's first start with talking about the cluster options. So in this video we are going to talk about cluster setup. Let's see what are the ways you can deploy Hadoop. So let's first talk about deployment modes. Hadoop can be deployed in three modes. Local job runner mode. It can be deployed on pseudo distributed mode. And third, it can be deployed in a distributed or a fully distributed mode. So let's first understand the entire working of Hadoop and we will look at all the three modes. So on a very high level, Hadoop is a typical software which is having a client server architecture. So it has a client and it has a server. So you have Hadoop cluster and you have a client. Now on the client you will simply have Hadoop client running the commands, and this client will have its own configuration. And here you have cluster which has master and slave nodes. So we'll have master and slave nodes on this particular machine. Now let's look at all the three modes out here. The first mode is local job runner mode. This mode basically is only for developers. As an administrator, you will never have to look at it at all. In this particular mode, the way things work is local job runner mode. The way things work is you have a single machine which will just have Hadoop client, and you will have Hadoop installation. Now this would work in such a way that none of the Java processes are running other than a simple Java process that you run for your program, and Hadoop will work on local file system. It will work on local file system. There is no HDFS involved. So technically what we will have is MapReduce libraries. So on a same machine you have Hadoop client, you will have your local file system, and you will have Hadoop libraries. So majorly it will be Hadoop MapReduce libraries. Now here what happens is you on your laptop, so this happens to be your laptop. So you from your laptop will submit a code that will be submitted to the libraries, and libraries will run your code on the local file system. In this entire process, there is only one JVM running, and that JVM is your program. Nothing else is running. So when you do a Java process status, you see nothing about Hadoop. All you see is that your program is running and your program is interacting with the Hadoop software, and Hadoop software is operating on the local file system, not HDFS. This particular way of running code, first, if you look at the characteristics, everything runs on a single machine within a single JVM. It's ideal for developers it operates on local file system, developers can now code from Eclipse and debug the code. No name node, data node and other processes required to run. This is how the local job runner mode works, and it's perfect for the developers. It's a blessing for the developers, but it is of no use to the administrators. So that is local job runner mode. In this case, everything is on a single laptop. So the next mode that we are going to talk about is called as pseudo distributed mode. So let's talk about pseudo distributed mode. In pseudo distributed mode, you again have a single machine. You still have a single laptop. And on that laptop, first you have is a Hadoop client so that you can submit your jobs. You have Hadoop libraries, that's the Hadoop software installed. But when you install Hadoop and run it, there are two important things. Your code will run on HDFS, not on local file system but HDFS. And on the same machine, all the master and slave libraries are running. So on your machine, you will have 6 JVMs typically that will have name node, data node, resource manager, node manager, secondary name node, and job history server. So typically there are 6 JVMs running, and this is called as pseudo distributed mode. The dictionary meaning of pseudo is false. In this case, entire cluster is running on a single machine, or in a technical way we can say it's a false mode. Now what happens is you submit a code that actually ends up going using libraries, it goes to these processes and it operates on HDFS. So this is again a mode for developers. So first step is developers will test their code locally, then they would deploy it on a pseudo distributed mode so that they understand how the code is going to perform on a real world cluster. So this is like a pre-check, or you can say a small staging environment for the developers where they can really run Hadoop on a single cluster. So the way it works is all Hadoop processes run on a single JVM or on a different JVM, but on a single machine. So that technically means 6 JVMs running on a single machine. Third, the file system used is HDFS. Fourth, it's absolutely ideal for developers to test their code before they submit it to the real cluster. So far in our course we've been using pseudo distributed mode, where in our course we have a single CentOS machine where all the services were deployed and we ran our code on HDFS. So in this course, the CentOS VM you've got, in the initial exercises we were using CentOS VM as an individual VM, and we were basically we've installed name node, data node, resource manager, secondary name node, and job history server. And what we did is we successfully ran all our programs. So that is second mode, pseudo distributed mode. So far we've seen two modes. One is local job runner mode, perfect for developers. Second is pseudo distributed mode, which is again for developers, where they can test everything in a real world kind of a cluster. And the third environment will be fully distributed mode. So as an administrator, when you get code from the developers to be deployed, make sure you check this, that they have already run it on local job runner mode and distributed mode, pseudo distributed mode, before you deploy it on a cluster. This shall save you a lot of effort. In case they have something wrong in the code, they should be able to check it at their end before they deploy it on the cluster. So this was second mode for us, which was pseudo distributed mode. The third mode is fully distributed mode. So let's look at what exactly is fully distributed mode. In fully distributed mode, what we have is, typically you'll have your laptop, which is going to be a Hadoop client, and you will have a cluster which will have a master and multiple slaves. So this is like a real world cluster. Fully distributed mode, we'll have name node, resource manager, node manager, data node, and we will also have secondary name node and job history server. On the laptop side, we'll just have Hadoop client, and we'll have configs that will connect to this cluster, that will help us connect to this cluster. So fully distributed mode is nothing but, it's production, also called as production mode. One master and multiple slaves, Client has its own configs to connect. Each slave has its own config, and master has its own config. Slaves connect to master using these configs. So a quick summarization, what we've seen is three different modes. The first mode is local job runner mode. That's for developers, so that developer can code and test it out. It won't use HDFS, it uses local file system. And the way it would do things is, it will let you even debug the code that's written in Eclipse. Second is pseudo distributed mode. This is again ideal for developers to test their code before they go to the cluster. In pseudo distributed mode, everything is running on HDFS, and all the 6 Hadoop processes, name node, data node, job resource manager, node manager, job history server, and secondary name node, all of them are running on a single machine, and it's ideal for developers to test before they deploy on the cluster. For the first level of course, where we were introducing Hadoop, majorly we did everything in a pseudo distributed mode, where on a single machine we installed Hadoop, we installed HDFS, MapReduce, Scoop, Pig, Hive, and we did everything on a single machine. And the third mode is going to be fully distributed mode. And in this particular mode, you have a master and multiple slaves, and all the slaves will connect to the master using configuration. This mode is also called as production mode. And for this particular course or this particular administration track, we are going to completely focus on the fully distributed mode, where we'll have a master and we'll have multiple slaves. So that is what is going to be our labs. So what we've seen so far in this course when it comes to the cluster setup is we've completely understood the deployment modes, that is local job runner mode, pseudo distributed mode and distributed mode. The next thing which is very, very important for us to understand is configurations. So let's talk about what exactly are configurations. On a high level, Hadoop is nothing but it's a client server model. What exactly is client server model? There is a client which will have libraries to connect to the master or the server, and server will basically provide that particular service. In Oracle world, let's say a client would be Toad, which is installed on your laptop, and Oracle server may be somewhere else. And with the file called tnsnames.aura, you will be connecting to the cluster. So in this particular section, what we are going to talk about is how does Hadoop connect, or how does Hadoop client connects to the cluster? That's one. What are the most important configuration files? What are the most important configs? We'll also talk about precedence, and we'll also talk about the format. So let's first talk about how clients connect to the cluster. Most important config files. We'll talk about precedence of config files and configurations, most important configs, and also the format of configs. So let's jump into this topic called as configuration. So the way we start setting up cluster is we typically purchase machines. And on all the machines, we will typically first simply install Hadoop. So we will install Hadoop software on all the machines. Later we will decide, so once you install Hadoop, you get set of configs. So when you install Hadoop, you get following config files. You get a lot of configs, but the most important ones are core site.xml, hdfs site.xml, yarn site.xml, and mapred site.xml. So this is what we end up getting when we install Hadoop. And Hadoop env.sh. Now these config files will be on every machine. Just for the clarity, we will minimize them. Now, as per these configs, mostly all the configs will remain same, and as per these configs, everybody would point to the master, and they would convey that this machine is running the name node and the resource manager. So this is how everybody knows that this machine is the master. Then on your laptop, what you would invariably do is simply have the client installed, or say Hadoop client, and on Hadoop client you would have the same set of files. So that's also called as a lot of times client configs. So in this client config also we will configure the name of the host, and that's how the cluster knows that this is where I'm supposed to connect. So that's how configurations work. Now what we are going to do is we are going to understand each and every configuration file. We will then understand few of the most important configurations. We will understand the format of configurations, and we will also understand the precedence of it. So let's get going. So let's first talk about the most important configuration files. So the most important config files, the first one is coresite.xml. Typically educates everyone about the master node of the cluster. That's the most important purpose of this particular file. The next file is hdfssite.xml, has all the settings that pertain to storage. Few examples would be block size, replication factor. So anything that pertains to storage would be stored in hdfssite.xml. The third file that we are going to talk about is yarnsite.xml. Now this file has all the settings that pertain to resource manager and node manager. Few examples would be resource manager host. And the fourth file is mapretsite.xml, has all the settings that pertain to MapReduce app master, like number of reducers. The fifth file that you may deal with is Hadoop environment.sh, mostly used to configure environmental variables like heap size for name node, data node, and so on. So these are 5 most important configuration files that you will ever deal with. And in our lab also we are majorly going to deal with the first 4 files and you will be looking at all the configurations. So now we are clear with the fact that Hadoop works in 3 modes and this whole game is played on configuration. 5 of the most important config files that we have are coresite.xml, hdfssite.xml, yarnsite.xml, mapretsite.xml, and Hadoop env.xml. Now let's look at a few properties of how XML files or how these XML files majorly look like. So let's talk of the format of these XML files. Typically the way Hadoop configs work is configs are written in XML format for most part. Other than Hadoop env.sh, for most part it's written in XML. And the format would be configuration property name, value, and that will be it. So there will be multiple properties. And we will have an end configuration tag. So fs default fs hdfs Delhi 8020. So this is how typically configuration files would look at. For most part, all the XML files would have configuration, property name value, property name value, property name value. One of the most important part about these configurations is there is an interesting precedence. So let's understand precedence in a very simple way. So let's go back to this particular slide. Now we have Hadoop client and you have Hadoop cluster. On the client you have client configs and on the cluster you have cluster configs. And an important part is configs can be specified multiple times. So same config can be specified multiple times, and configs work on precedence. So what does precedence means? Let's understand. So the highest precedence will be something that's in the code. Second precedence will be what is in the client, and third precedence will be cluster config. So let's understand this with an example. Let's say the number of reducers in the code is 10. In the client config is 6, and on the cluster it's 1. So number of reducers would be set in map_site.xml. So in our code we set it to be 10. On the client we set it up to be 6, and on the cluster we set it to be 1. And in this case, when this code runs, number of reducers will be 10. Number of reducers will be 10. So that's how the precedence works. So a quick recap, what we've seen is Hadoop can be deployed in local job runner mode. Hadoop can be deployed in a pseudo distributed mode. Hadoop can also be deployed in a fully distributed mode. Now everything works based on the configuration. So we've seen that Hadoop has config files. 5 of the most important config files are codesite.xml, hdfs-site.xml, yarn-site.xml, map_site.xml, and hadoop-env.sh. These are the most important files. The format of the XML files, most configs are on XML, and the format of the XML files looks like configuration, property, name, value, name, value, name, value. And the configs also follow a precedence. What is in the code is the highest precedence. What comes in the client config is second precedence, and the lowest precedence is on the cluster. To an example, if number of reducers in a code are 10, on client it is 6, and on cluster it is 1. So when you run this particular code, the number of reducers that will happen is going to be 1. Now, this may sound to be a big limitation. imagine as an administrator, everything that you do, a developer can change it. So as an administrator, you have a control of deciding that, okay, number of reducers is, let's say, 1. But the developer is very simply putting it in the code and it's overriding it. So as an administrator, if you don't want that to happen, in the property, just make it final is true. With this, what happens is there is no way a developer can change or override the setting. So if you make number of reducers to be 1 and you make it final as true, there is no way a developer can make number of reducers to be 4. So that is absolutely possible. Now, what we are going to talk in the next topic is what are the most important configurations and a bit about topology. So let's quickly reiterate and put notes here so that we go to the next topic. We now understood how clients connect to the cluster with the help of configuration files. We then understood the most important configuration files. The most important configs that we have are core site.xml, HDFS site.xml, yarn site.xml, mapred site.xml, and Hadoop env.sh. We've also understood precedence. We've understood the format of strings or format of configs. The next topic we are going to talk about is the most important configurations. So let's do that right now. So the most important configs that we have in core site.xml, the most important config that you will be dealing with is fs default fs. So this is to educate everyone about who is master. That's one of the most important setting that you would put in core site.xml. The next file which is important is HDFS site.xml, and the most important setting that you are going to have is first will be replication factor. So DFS replication factor is default 3 and you can change it. The block size, DFS block size, by default it is 128 MB and you can change it. The third and the most important setting is data node dir. This is a setting where you specify when the data is written, the data is cut into blocks, and in which folder will data node write its data. That's gonna be our next important setting. The fourth important setting is name node dir. Now in this particular setting we will say that which directory is name node writing its metadata. So that is in HDFS site.xml. So these are 4 most important settings that you put in HDFS site.xml: your replication factor, block size, data node directory, and name node directory. In yarn site.xml, there are 4 most important settings that you're going to put. First is resource manager hostname. This is our way of educating where exactly is resource manager running. So this is that particular setting. The next setting is log aggregation. Now if you look at logs, each machine will have its own logs, and that's going to be very, very difficult for us to track. So the better idea would be to put all the logs in HDFS and we can look at data or logs from HDFS. Then you specify log locations. So where exactly will the log go. And the most important, or the fourth setting that we are going to have is the intermediate data. So when mappers write their data, they write it to local file system, and in yarn-site.xml you can specify them. So in code-site.xml, fs default fs is one of the most important config. In hdfs-site.xml, replication factor, block size, data node directory, and name node directory are the most important settings. In yarn-site.xml, we've resource manager, hostname, log aggregation, locations, and intermediate data is the most important setting. And in mapret-site.xml, it's the history server host. That's a setting that's very important. And second is MapReduce framework name, that is yarn. So these are some of the settings that you are going to do when you do a cluster setup in the lab. In the lab, more or less you will be playing with each and every setting and configuring that manually as well as automatically in the Cloudera Manager setup. So a quick recap of this particular video or this particular chapter. We've seen deployment modes, we've seen configurations. In deployment, we've seen local job runner mode, pseudo and distributed mode. In configurations, we've seen how clients connect to the cluster, most important config files, precedence, and we've seen the format of configs. The next thing we are going to talk about, so now that we understand how clusters are set up and connected, let's quickly talk about real world topologies. So what exactly is a real world topology? Is if I'm setting up a real world cluster, let's say 50 plus nodes or 20 plus nodes, how will my configuration look like? How will my configuration look like? Let's see what we are gonna do. So if we are talking of a cluster that's 20 plus in size, this is what we will have. One, and you'll have slaves. You'll have name node, standby name node. We will have a resource manager. We can have a standby resource manager. Other services which you will be doing it in the lab, and we'll be talking about them more in the future videos, but let's just put them in black. Journal node, Zookeeper server. So these are two more services we'll run. So we'll need 3 journal nodes and 3 Zookeeper services. We'll talk about it in a bit of a minute. We will also be running a job history server. And on the slaves, invariably we'll be running data node and node manager. So in a 20 plus cluster, this is what we'll do. But imagine if our cluster is just 3-4 node, whatever you see in black other than job history server let's just say it's an optional service. So journal node zookeeper, we will not do it in a 3 or 4 node cluster. We will simply have one master which will just have name node, standby name node, resource manager and other services. So this is a recommendation for a 20 plus node cluster. So this is a recommendation for a 20 plus node cluster where you will do all these services. Imagine we were doing a 3 node cluster or a 4 node cluster which is a POC cluster. So if it was a POC cluster, what we are going to do is we may just have just one master. We may remove these services. There would be typically no standby for a typical POC cluster. Put name node, put resource manager. There will be no, and we may have a secondary name node. So you just have everything on one master for a POC cluster. So what we've seen is, if you have a 20 plus node cluster, you will typically have 4 masters. One master will run name node, standby name node, resource manager, standby resource manager. On any 3 masters, you will run journal node and zookeeper. We'll see about them later. And we will also run a job history server. So that is how you will typically define topology of your cluster. That's how you typically decide. Typically a POC cluster, you will have one master. If you go big, you will eventually break it down to 4 masters. You will eventually have 4 masters. So this is all about topology. If you have 20 plus nodes, you will typically go for 4 masters and rest of the slaves. So on the cluster side, deployment modes are clear. We are clear with configurations. We are clear with the topologies as to how we should go for a topology. Typically for a POC, one master and multiple slaves. For a 20 plus node serious cluster, you will separate out the master. Below 20, and if it's kind of a production, you may have 2 masters and decide which service will run on which machine. That will be the way you will go about it. All right. The next thing we are going to talk about is logging and port numbers. And we will also talk about setup and management options. So let's talk about logging, port numbers, and setup and management options. So now that our cluster, we understand how cluster is going to be set up, let's first talk about setup and management options. That if I want to set up a cluster, so let's understand the problem. Okay, we are clear with the cluster functioning, but how do we set it up? Well, there are majorly 2 options. First is manual mode, where you install Cloudera's distribution from cloudera.com and manually set up each and every service. So in this case, you buy machines. On each machine, go install Hadoop and then configure, wire them together and make them work. Second is automated mode, where you use a tool like Cloudera Manager, and that tool will do everything, and it functions on the wizard driven approach. Now as far as this course is concerned, we will be doing labs in both the modes. So as far as this particular course is concerned, you will be doing entire cluster setup on a manual mode as well as on the automated mode. So you'll have manual mode as well as automated mode done for yourself. And two more topics that we will be looking at in the cluster setup area. One is port numbers. First, port numbers, they are default, but they can be configured. Ports in Hadoop are of two types. One is for the web and another is for internal communication. So if we want to view the name node UI, we've seen it in the basic course that the URL was 50070, but when data nodes want to talk to the name node, the port is 8020. So let's look at a few port numbers. So we say process, talk of web, and we talk of internal communication. So when we are talking of name node, from the web it is 50070, we've already done that, and 8020 is for internal. Data node has multiple ports. Typically from the web you will have 50075, and here it is 5010. That's the port that data node deploys. Resource manager works on 8088, and for internal it is 8032. Node manager works on 8042, and internally it works on a port starts with 5 something. This could be actually a variable port depending on where it gets. Sometimes it's in the series of 35,000. So it's not a fixed port where node manager will work. So these are some of the port numbers that Hadoop uses. Job history server on the web works on 19888, and it is 1900101. So this is the port numbers, or these are some of the default port numbers that are being used for our communication, And can this be customized? Yes, they can be customized. And but do you need to do it? Not really. You just leave everything to the defaults. The next thing we are going to talk about is the logging. Well, all Hadoop processes, they have logs in where log folder. So for HDFS, the location will be where log Hadoop HDFS and for the process. So all the locations are going to be where log, and logging is covered as a demo in the code walkthrough section. So in the code walkthrough session, you will look at each and every log file and understand it in a better way. So in the cluster setup side, in this particular section of the course, what we've seen is we've seen the deployment modes. So when we are talking of deployment modes, we've seen local job runner mode, pseudo distributed mode, and distributed mode. When it comes to configurations, we've seen how clients connect most important configs, precedence and formats. We saw how topologies work in real world. We've also seen how you can set up and manage your cluster. There are two modes, manual and automated. Manual is you doing everything, and automated is Cloudera Manager doing it. And the third or the next one we saw was logging as well as port numbers. So we saw there are two types of port numbers, and we also saw the logging services. Logging would be covered in a code walkthrough section or the cluster walkthrough section in detail with the log files. So this is all that you need to know for the cluster setup perspective. Most important topic out here would be to understand that there are 5 most important config files. Thanks for watching this video, and in the next video we are going to talk about cluster planning.